Welcome to Coffee, Contractors, and Concrete, a podcast series focusing on all aspects of the surface preparation industry and brought to you by the industry experts at Buy Manufacturers Direct. Joining the podcast today is Substrate Technology President, Industry Patriarch, social media educator, and leading subject matter expert, Josh Jones. So now let's move on to one of the biggest debates when it comes to concrete grinding, wet versus dry. It seems like the industry has evolved from wet to dry, and now you're starting to see some tendencies back to wet. Talk a little bit about the differences, the pros and cons of each. If I'm a new contractor, what am I looking from an equipment standpoint that I have to invest in one process over the other, and the benefits of one process over the other?
If we're discussing wet cutting or dry cutting as it relates to surface preparation, then I would say on surface preparation, I'm not really going to want to cut a floor wet if I don't have to. And there's a lot of reasons. I would say that I would only cut it wet in some portion of a process, like maybe adhesive removal. And even then, I don't know that I would do it fully wet. But in surface preparation, I think the best way to answer that would be to say as little, as often, or as infrequently as possible would I be cutting a floor wet. And the reason being is because I'm going to put a coating on the floor. The last thing I want to do is create mud that then I'm now responsible for 100% removing, because that mud could serve as a future contaminant. On the topic of polished concrete, then absolutely I would be using water for part of the process. And the reason being is because I'm trying to process a hard surface, just like a granite or a marble restoration contractor uses water. I would be using water for that. With regard to surface preparation and why I want to stay dry, as I said, I don't want to create a contaminant that's liquid that then I'm tasked with having to fully remove before I put the coating on the floor. There is a way to improve the cut of the machine so that it cuts the floor, the diamonds cut the floor more effectively, and that would be with a secondary abrasive like sand or silica, and then a spray mist of water. But that's still done under dry dust collection. I'm only using enough water to give some weight to that sand, and also because I'm using dry dust collection, it's not going to be such an amount of water that it would affect that filter setup inside the vacuum, because it is a dry vacuum. On the polished concrete side, as I said, there are certain steps in the process that have to be done, in my opinion, in order to get full processing and to get the full polished result that the floor is capable of providing. Then some steps will have to be done wet. And the tools are made to do it that way as well. There are plenty of people that will polish dry, and I understand that, but I will always get the best result out of a polished process if I'm allowed to use water for some steps of it. And again, this is something that's been borrowed from the stone industry. The reason water is being used is because we have a hard material that needs to be processed a certain way that if it was possible to do dry and get the same result, we would be. The fact that we're using water is because that's what we need to do to get that result.
Going back to the grinders themselves, can they all do wet or dry, or are there specific models or types of machines that should be used specifically for dry versus wet?
Rotary is definitely more suited to doing wet cutting because of the action of the heads. We'll go back to the difference in the way that a floor is cut with a rotary versus a planetary. A rotary, whether it's a 2-head or a 4-head or an 8-head machine, 2 heads, 1 head, 50% of the heads on a machine are going to be going clockwise. And then by its design, that means the other half, or the other 50% of the machine, are going to go counterclockwise. So of course, if I have a 2-head machine, one is going clockwise, one's going counterclockwise. That action is always pulling into the center of the machine, no matter the rotation. Whether the rotation is switched at the motor, those heads are always going to be pulling into the center of the machine. Yes, it is also going to want to throw out, but the thing is that the shroud on the outside can be dropped so that the water stays inside the cutting area. That means I don't have to put as much water down or keep pushing the water in, because it's not constantly trying to throw it away from where it needs to be, which is under the heads. With a planetary, because of the nature of the cut, the thing that makes it very aggressive and very productive, that makes it turn one way while the main drum is turning another way, that movement of those tools on the floor is causing that water to splash everywhere. It really doesn't get a direction. And that's really how the machine is able to cut the way it does. It's attacking the floor from many different directions. Well, the water that needs to stay under the tools with all that speed and all that movement is constantly getting thrown away from those tools. The shroud can keep it in, but the problem is that those tools are always trying to throw it somewhere else. And so to answer your question, rotaries were originally designed to cut wet on terrazzo, which is, really where this machine style comes from back in the 60s, maybe even sooner than or longer ago than that. They were originally designed and then have evolved with those wet cut steps in mind. So there's no reason the design would have evolved into something else, because wet cutting on epoxy or cement based terrazzo is still the way it's done. Some steps are done wet. So it's something that from it's like a legacy effect with the rotary. It was made to do the work wet. It still does some of the work wet. And for that reason, they're still made the same way. Planetaries, on the other hand, they can cut wet. But the dynamics of what happens underneath the machine, the physics of it, makes it a little more difficult. But there are plenty of people who use planetaries to cut wet.
Let's move on to power. So everyone's grinders come from anywhere from a 110 to a hand grinder, even some 18-inch planetaries and a 110 volt, all the way up to the larger 460 volt big machines. Is more power better? Is bigger better for grinding? Why do they come with such variations of power? And if I'm a contractor and I want to get the biggest bang for my buck, should I buy bigger with more power? Or am I okay staying with like a 220 volt machine, smaller, more maneuverability, more easier to mobilize? Kind of, again, from that perspective, if I'm a new contractor looking to buy my first machine, run through the criteria of what I should be looking for and the questions I should be asking myself and my representative when looking for that first machine.
What I usually ask people when they basically ask me that same question is, it's a bit of a loaded question that I ask, which is, what do you expect the average size job is going to be that you'll undertake? If they are chasing commercial work and it's 10, 20, 30,000 feet, then we're going to be more talking about three-phase. It doesn't matter if it's low volt or high volt, but we're talking, 12 to 1,500 pound machines, 12 tools, three-phase equipment. Bigger machine, bigger dust collector, bigger power generation, which is required because of the square footage they're doing. If they say the biggest job they expect to do is 1,000 feet, then I'm going to probably be steering them more towards a machine that's going to be doing 400 or 500 feet an hour, simply because that much square footage, it's going to be difficult to justify. If I have a bigger machine that I could do, let's say 1,000 feet, with a big machine, if I could get it done in 20 minutes versus a small machine in an hour, what am I really getting for that extra 40 minutes of savings? I mean, yes, I would have less labor, but to be able to turn it out that fast, do I have the labor and the workflow to be able to get that job done quicker, or did it just get ground faster? And so to answer your question, usually my first question for them is going to be, how many square feet do you expect to be doing? Like right out of the box. And if they can answer that, then it's going to be much more helpful. However, again, they may say that, I'm going to do a couple garages to practice, but I got this landowner, this land management company, they want to give me 50,000 footers. Then, okay, then we'll talk about big equipment. But, when it comes to surface prep, especially with grinders, same goes for blasters too, same goes for scrapers. It's really a matter of, when it comes to the size of the equipment, how much does needs to be done in a day? And then at that point, we can look at the equipment size based on what the demand for productivity is. Of course, along with that demand for productivity comes bigger motors, more power requirement, bigger dust collection, bigger power generation. Everything gets bigger, but that's the only way in surface prep to go faster. More power, more weight. That's the only way to go faster.
Okay, last question on the mechanics of the grinder. I've heard you talk in great detail in the past about head pressure, and how important that is to have a certain amount of pressure on a diamond to make it more effective when it's cutting. And I think that specifically goes to the design of the machine and how the weight of the machine is placed over top of the cutting heads. Talk a little bit about that, why that's so important, and why it's important to the result of the profile you're trying to create.
Well, when it comes to rotary designs versus planetary designs, they're not the only machines, of course, that have a motor directly over the cutting area. I would say that with the rotary, because of the power input demand that's needed to turn the diamonds on a rotary, we get to take advantage of more copper, more cast, just more weight because it takes more power. So the motor, of course, gets heavier. And that weight is put to good use through the weight that goes over the diamonds. As far as head pressure or tool pressure, that's really going to be more related to the tool that I choose based on how much pressure is above it, what it's expected to do, what is a reasonable amount of life that can be squeezed from that tool, because in order for a tool to cut, it has to wear. So it's not an exact science because the medium that I'm cutting is always changing. But what a rotary does with that motor directly over the head is it does provide an extra amount of mass that then translates or transfers through those tools to the floor. Pressure is important, but pressure also, if the tools are not sharp and cutting, pressure can contribute to glazing or rounding over the tools because, of course, the heat that builds up from friction is so severe, perhaps it's actually melting the sand or the dust and it's causing the diamonds to stop cutting. But weight is important. It really is something that as a contractor, I think where it can become confusing or something that I need to know would be a matter of how does that relate to the tools that I'm intending on using? If the tools I intend to use are from a machine that's 1,200 pounds and 90 pounds of head pressure, and I put it on a machine that is only half that, it's probably fair to assume that the tools are not going to be as aggressive because they were designed to have double the pressure over the top of them than on, let's say, the smaller machine. Even though I can attach them, the smaller machine I can attach them to doesn't have the weight that the other machine had. So those tools might not cut. So again, we're back to that weight and power thing that no matter what, for surface preparation, I cannot escape the fact that the weight and power are the two biggest influences over being productive or being, let's say, disappointingly slow.
And that also kind of answers one of the most common questions when someone's buying diamonds is how many square feet am I going to get out of this diamond? And it sounds like that's all reflective on what kind of machine you're putting it under, how much head pressure is it, the concrete itself. There's a lot of variations, and we'll cover that in the diamond sections in a later podcast. But that in essence is an impossible question for anyone to answer because the elements that surround that diamond on how it's going to be used are different in every application.
Definitely. In defense of the manufacturers of the diamond tools, whether they have a very close attachment to the industry and they understand how their tools are used, or they simply are making the formula and in a manufacturer, they create the tools and the industry consumes them and they have very little knowledge of the industry. In their defense, concrete hardness and density and materials, and then of course the differences that can be seen not just in America but around the world, a tool's performance and life, it's probably safe to assume that at some point for somebody somewhere they worked. They cut nice, they wore well. If I take that same tool that's was working wherever it was tested and then put it on a softer slab or a harder slab, and then it burns up in a third or a quarter or a tenth of the time of what it should, of course that drives my cost up, or it doesn't do anything, the conditions are different. The tool is the same, but the conditions are different. So when it comes to trying to figure out what tool is going to be the correct one for use from a standpoint of longevity, which of course affects price, and then also from a standpoint of productivity, which of course affects price through labor, it's something that I would say when people ask me, what's a good diamond? Well, first question is, what machine do you have? Because again, we need to identify what are the physics that cannot be changed. If somebody calls from Alabama, as an example, with a certain rotary style machine or a planetary, it doesn't really matter. But that knowledge is then going to at least help us narrow down to a smaller group of tools that would be appropriate for them. Because it's easy to find a tool that cuts. But the problem there is if somebody says, I just need a tool that cuts, but it burns up in a tenth of the time, their cost has now gone from maybe a nickel a foot to 50 cents a foot. And that's really where, contractors can get frustrated. It seems that every turn they're having to buy a different tool. But, when it comes to trying to dial in what would be the correct tool, it really boils down to working with a supplier that understands the area that it's being used, the machine type, most important, and some general sense of what the concrete condition is.
This concludes episode 3 in a series of podcasts focusing on the basic principles of concrete surface preparation. Make sure to join us for episode 4, where we begin the discussion of shot blasting and migrate the conversation to other popular methods of mechanical surface preparation. For immediate access to hundreds of industry tutorials and product demonstration videos, we invite you to visit Biomanufacturers Direct YouTube channel. Simply visit the Biomanufacturers Direct homepage and click Watch More Videos. New videos are added weekly, so don't forget to subscribe and click that bell icon to be notified when we post a new video.